Welcome back to Chapter 5, Chemical Quantities and Reactions. Um, Another type of chemical reaction is an oxidation reduction reaction, and it's such an important reaction and in chemistry that it has its own chapter. So in addition to those other combination, combustion, that type, we also have what's called an oxidation reduction reaction. These happen a lot in the body as well as in nature and in industry. An oxidation reduction reaction occurs when you have two elements that are changed in some way. You always have one and the other, because what happens is you have a loss of electrons, which is called oxidation, and you have a gain of electrons, which is reduction. Now, if you try to think this too hard, it's going to confuse you. So pick one and remember what it is. Okay, so if you want to say, okay, I know oxidation, it's going to lose an electron. All right, so you know reduction is the opposite of that, because reduction is the gain of an electron. It gains negative charge, therefore is reduced. But like I said, pick one, remember what that one does. So oxidation is the loss of an electron. And so if you have an electron available and you lose it from A to B, then A no longer has that electron, B does. So A is oxidized, B is reduced. Okay, and they always go together. You cannot have one without the other, because the electron has to go somewhere. And so one gives it up and the other one receives it. You see oxidation reduction in a whole lot of different places, like when you see copper or other metals that get that patina, they call it, that change in color, or like iron rusting. That is an oxidation reduction reaction, because it uses oxygen often to make that happen. So in the green patina I was talking about on copper, because it was bright and shiny at one time, and then as it weathers, it builds up this oxidation. And so what's happening is that you have copper metal, and when it is in contact with oxygen, it over time produces copper oxide on the surface of the metal. Okay, and so I've got a little thing here to help you remember that oxidation is loss of electrons. Okay, and reduction is gain. So if you remember oil rig, oxidation is loss, reduction is gain, then that should help you remember these. Okay, but like I said, if you just remember one, that would be good, because what's happening here is two things. You're having an oxidation of copper, so you have copper metal, the shiny nice stuff, that's going to a copper ion, and in order for that to happen, it's losing 4 electrons, while oxygen is gaining 4 electrons, and so you get 2 of the oxygen ions. Okay, so the oxidation is the loss of electrons. It used to have the electrons over here. Okay, it had 4 electrons over here, and it gave them away, so you show them adding to this, because you've got 2 times a plus 2 is a plus 4, and then plus 4 electrons. In oxidation reductions, you balance the electrons. So it's a little bit different from what we've seen before. Okay, so in copper and zinc, they can do this, where zinc replaces copper. Like you have a solution, and in that solution you have copper plus 2. That's what is in there making that blue. And then you have a zinc metal piece of metal or rod. You put that in this copper solution, and what happens is the copper that was inside the solution attaches to the outside of that zinc and becomes copper metal, and it looks like copper, like a shiny copper penny, and it plates that onto that zinc. And so on a molecular basis, what's happening is this copper ion plates as copper metal, and it has to give up 2 electrons when it does that, okay, because it has to gain 2 electrons to do that because it was a +2. So to get to a 0, which is what copper metal is, it will have to have 2 minus charges, okay? And so by doing that, those 2 minus charges have to come from somewhere, and so they come from one of these zinc metals, and the zinc metal then becomes the zinc ion +2 because it took 2 away from the zinc. Does that make sense? So the zinc, which was a 0 because it was the metal, goes to zinc 2+. The copper, which was in solution, goes to copper 0, okay? So in order to do that, the zinc has to give up 2 electrons, so the electrons go away, and the copper has to gain those 2 electrons. Okay, and so this is what's happening on the surface of this zinc plate. So oil oxidation is losing electrons. Which one is oxidized? Which one is oxidized? Which one loses electrons? Which one was metal? Okay, where reduction is gaining the electrons, which one gains electrons? This one, the copper, right? So oxidation is losing, reduction is gaining. So let's look at these and see if we can identify which is oxidation and which is reduction. Okay, so how do I know that this one is oxidation? And we got to check them close because with the way these learning checks have been going in this chapter, we got to watch them close. Okay, 10 was a 0 charge. It went to a +4. In order to go to a +4, it had to do what? Give up. So it lost electrons, right? Oxidation is losing electrons. Iron, 3+, if it gains 1 electron, that means that it's 1 less positive, so it's an F+2, so that would be reduction. And in this final one, this is a 0 because it's elemental, +2 electrons. Now, chlorine cannot form a Cl2-. Okay, chloride will only become a Cl. So that's why we have to give a coefficient in order to say how many of these are on this side. Notice what that we're doing is we're balancing the pluses and the minuses. Okay, so we've got +3 and -1. So 3 minus 1 is a 2 plus, and this is a 2 plus. This is a 0. 4 minus 4 is 0. This is a 2 minus. This is a 2 minus. See what we're doing here? So we're making sure that our electrons balance. Electrons balance. Very important in an oxidation reduction. In light-sensitive sunglasses, UV light initiates an oxidation reduction reaction where you have silver in the form of a +1 ion, and you have 2 chloride ions, and they give you silver and chlorine. All right, and so what it's asking you is which one is oxidized. Okay, and the way you do that is you've got 2 Ag pluses that go to 2 Ags, and remember elemental is going to have a 0 charge, and then you've got 2 Cl minuses going to a Cl2, which should be a 0 charge. Which reactant would you say is oxidized? Well, you had to do what? In order to go from a chloride to a 0, did you have to gain or lose electrons? You lost electrons, right? So oxidation is loss of electrons. In order to go from a +2 silver to a 0 charged silver, you had to gain electrons. Okay, so that one is reduction. In biological systems, things like the electron transport chain and other parts of biology are important because when you oxidize something, you lose protons and you can create something called a proton motor force. That's the basis of a lot of energy capture and cellular respiration. And so you can transfer two hydrogen atoms, which is going to have to do an H plus and an electron for every one. So what you're basically doing is you're taking hydrogen ions and the electrons, and you're forming an oxidation reduction potential, it's called, so that you lose hydrogens on one side and you gain hydrogens on the other. So it's an oxidation where you lose the H plus and the electron on one side, and then where you gain the H plus and the electron on the other side. And so this is a typical thing that you see in biological systems. So oxidation always is a loss of electrons. Reduction is a gain of electrons. Sometimes in oxidation you'll see an addition of oxygen or a loss of hydrogen, or conversely in reduction a loss of oxygen and a gain of hydrogen. But always, always, always loss of electrons, gain of electrons. So that's what you can always go by. And this is just an example of taking this to hydrogen as a 0 charge. This would actually be if you wrote it like that, and it would go to the hydrogen. In this one, you have the hydrogen, it goes to another hydrogen using oxygen. These are just examples. You not really have to be able to look at those so much, because when you do your oxidation reductions in A&P and things, you will talk about adding oxygen as oxidation or losing hydrogen as oxidation. And so that's the end of 5.5. So what you're responsible for is being able to tell which is the oxidation, which is the reduction, based on the electrons when the equation is written out for you, knowing what the definition is. Okay, you don't have to get real complicated with this. Do your mastering and do some practices on this and you'll be fine.